What's up, Tea Cats? Dylan here from Moo Mountain Tea. Today we have chapter 2 of the masterclass on tea, which is about tea plant biology and cultivation. To truly understand tea flavor and how tea impacts the body, it is essential to understand the basic elements of tea plant biology, as well as how tea plants are commonly cultivated. As always, to kick off the chapter here, I'm going to start with a one-sentence summary of all of the content of this chapter. So here it is. Tea plants are perennial trees in which unique leaf biochemistry reflects their unique climatic preferences. High concentrations of caffeine, polyphenols, and L-theanine allow tea plants to thrive under warm, humid, and mountainous conditions. Next, we put this sentence under the microscope, cultivate the succulent fruits of knowledge, and catapult you out of this video with a crystal clear understanding of tea plant biology and its cultivation.
会把这个传统茶文化带回去美国，在那边推广一下。
The tea plant is so unique biologically. It is really a special plant for a few reasons. The first reason, and this is kind of the most important one, is its polyphenol content. So tea leaves have 20 to 30% of their dry matter as catechins. And these are the antioxidant polyphenols that we know and love tea to provide us with. So, and these have enormous health benefits. So people starting maybe 2-3 decades ago, they measured polyphenol contents in different fruits and vegetables. And they've started to think that that's why these plant foods are so healthy for us, is because they're really rich in these polyphenols. Tea is just loaded in these things. They have a higher concentration of these than basically any other plant that we consume on a regular basis. They are bitter, right? They taste bitter, and we'll be talking about that more in later chapters about tea quality and assessment and tea tasting, but they are fantastic for our health. So you can think of it like a medicine. So polyphenols, number one. Big aspect of tea plant biology. The second aspect of tea plant biology that I think is critical is the fact that tea plants are the only species of plants to naturally synthesize L-theanine. L-theanine is a non-protein forming amino acid, and it has enormous health benefits for us. It's less studied than those polyphenols I was just mentioning because polyphenols are really abundant in tons of plant products, so it doesn't matter if you're studying tea or cabbage or apples, right? You're gonna encounter polyphenols. L-theanine is tea specific, so there's less literature about it and we know less about it, but what we do know about it is that it has very calming anxiolytic effects, anti-anxiety effects. So it's this really special amino acid produced only by tea that calms you down, and what it does is that it synergizes with caffeine, which is the next compound we're gonna talk about, to create this really relaxed buzz. So the caffeine is a stimulant, it kind of perks you up. But unlike coffee or other caffeinated products that kind of give you some of the jitters, make you jittery, L-theanine calms you down at the same time. So it kind of creates this meditative focus mindset, which is really cool, and that's part of the reason why I love tea so much. So L-theanine is very abundant in tea, and it varies by tea cultivar, but it tastes sweet and umami, which is really important because that is what counteracts in part the bitterness and astringency from the polyphenols. And that's what makes tea drinkable, right? Because if it was only polyphenols, then it would be too bitter and it wouldn't be as widely accepted as tea is today. So L-theanine, really cool, really unique molecule. That is a very notable and cool feature. I rank that 2 after polyphenols. So now we have polyphenols, L-theanine, and the third one is caffeine. So caffeine is an alkaloid. That is just a classification of plant compounds. And caffeine, everyone's heard of it. There's over 100 plant species that naturally produce caffeine, but tea has the highest concentration of caffeine of all those plant species. And a lot of people don't realize, they think coffee is more caffeinated than tea, which can be true, but the thing that people neglect to realize is that when you're making a cup of coffee, you use 10 grams or more of coffee beans for a small cup. With tea, in my little gaiwan here, I might only have 3 to 4 grams. So basically 1 gram of tea leaves versus 1 gram of coffee beans. Tea is the most caffeinated. That's cool. Caffeine, obviously it has these psychoactive stimulatory effects on us. It also is healthy for us in moderate quantities, right? Too much caffeine affects your sleep quality. That's bad. Sleep is absolutely essential to health. But a lot of studies show that a good dose of caffeine daily can be really protective for your brain and confer a lot of other great beneficial effects for health. So caffeine's cool. It's bitter, so that's going to affect flavor, right? Caffeine is actually a nerve poison for insects, right? So that's the natural insecticide that tea plant specifically, produces in order to kill insects that want to bite it. So that's cool. Those are the 3 major classes of compounds, and in terms of understanding the tea plant, its biology, its major significant compounds that are important to its health, the health of tea plant and our health, and the experience of drinking tea. Those are the big ones. Now, let's get into the cultivation side a little bit. Tea plants, they derive from high altitude mountainous tropics. So you can imagine the low latitude regions that push up into the Himalayas. So it's right around Sichuan, Yunnan. That type of climate is where tea plants come from. That is their evolutionary home. Like humans, we come from the Rift Valley in East Africa. The tea plant comes from the mountainous hills of Yunnan, Sichuan, Guizhou. There's a big plateau there that kind of pushes up to the Himalayas. That's where tea plants are coming from. So when we're cultivating tea, it's best for us to try to emulate those conditions in which the tea plant evolved. So a big part of that is shading. If you'll see a tea plantation, you'll see they'll have shade trees, right? Because when you're growing in the forest of these areas, you have larger trees, and tea plants kind of evolved in that lower canopy level, right? So they don't do well when they're just getting blasted with sun all day long. So in terms of cultivation, shade is key. Now, the big issue with cultivation is that, and this is kind of true for cultivating any crop, is that these plants didn't evolve to be shoulder to shoulder, neck and neck with 100 different plants surrounding it on all sides. That's difficult. And so what we're talking about is an agroecosystem, which is we're trying to build an ecosystem where these plants can thrive, but still do it in a way where we can cultivate large quantities of this crop and consume it ourselves. So that's tricky. In the dimension of tea cultivation, you have these really, really densely planted plantations, and then you have it ranges all the way from that to like wild tea growing conditions, which is just the tea plant growing by itself in the forest. So we are kind of working on that spectrum of cultivation, and it's all about planting density. How densely planted are these tea plants? And what we're finding out through trial and error currently is that if you plant the tea plants too densely, they don't survive very long. It's not a sustainable tea cultivation method. What tea plants do is they prefer acidic soil conditions. They prefer a pH of about 4.5 to 5.5, right in that range, which is very acidic for plants generally. So they prefer acidic conditions, and here's the thing. So this is tying together biology and cultivation. They prefer acidic conditions, but they also actively acidify their own rhizosphere, which is the soil surrounding their roots. Yes, they like acidity, but they're also acidifying the soil around them, which is difficult because if you're planting super high density of tea plants, then the soil continues to acidify past that 4.5 threshold where tea plants survive. That creates environment for disease and pathogens to thrive, which means people need to use chemicals to treat it. It's not good. It's not a sustainable method. So these little features of tea plant biology are actually what determine how we can cultivate it most successfully. So now you can kind of see why I'm tying these together. It's the biological tendencies of this plant that determine how we're able to plant them together and in what style we're able to cultivate them. Obviously, farmers want to plant as many tea trees as they can because that generates more profit. But the problem is 10 years later, 15 years later, when your soil pH is 3.5 and the tea plants are not thriving, they're not doing well, and you have to use all this external chemical fertilizers and applications, is it still profitable? Not really. That pH topic is critical right now. It's a bit of an epidemic. It's a tea plantation soil acidification epidemic. These soils are acidifying past the rate at which we can sustain. That's a problem, and that gives you a look into the interface between biology and cultivation of tea. And so just to circle back to talk about those compounds that we mentioned earlier. So I mentioned the use of caffeine as a natural insecticide in tea plants. Polyphenols also, they're antimicrobial, they're insecticidal. They are also protective against UV irradiation. The polyphenols function within the tea plants to help it fight all these different stresses, these biotic and abiotic stresses that tea plants face. And the different ways, through shading or not shading, or through different fertilizer applications, you change the amount of polyphenols in the leaves, and that changes how the plant interacts with the environment. Now, L-theanine too, just to round it out with that third one that I mentioned, that's more of just nitrogen transport. Like I said, we're still figuring out L-theanine, and it might have more uses than just that, but from what we know of it now, tea plants take up a ton of nitrogen. They're very nitrogen thirsty plants. They take up the nitrogen through the roots, they turn it into L-theanine, and that's like its transport unit. And then that can be moved up into the leaves and then turned into polyphenols or other amino acids for protein synthesis. So all of these compounds, the polyphenols, the L-theanine, the caffeine, these are entirely mediated through the tea plant's interaction with the environment. And in the context of cultivation, we as the farmers, as the growers, are creating that environment. So where we put the tea plants, how we treat them, how we fertilize them, the shade that we give them or not, those are what create the environment for the tea plant. And the tea plant then works with the environment through its biological processes to create these phytonutrients, these compounds that we then extract in hot water and drink and enjoy. There's a lot more to unpack with that, but for now, I would love for you to know polyphenols, L-theanine, caffeine, those are the biggies for biological components in tea. I hope you enjoyed these couple of tidbits, and we are going to see you back for chapter 3, which is tea processing. Chapter 3 is tea processing. This is going to be fun. We're talking about those 6 major tea types, which are so different from one another. You would never guess that they're from the same leaf, but it's all due to this processing, this craftsmanship, working with the tea leaves. That is a cool topic. That's what we're getting into in chapter 3. If you liked the video, like, subscribe, stick around for chapter 3. Just have some tea, enjoy it, kick back. Thank you for watching, and I'll see you in the next video. Peace.